So in section 7.1 part 4, I just want to reiterate something that I said in the previous part. The doubles only occur one time, meaning that a 1-1 doesn't occur twice in that listing, and a 2-2 only occurs one time. So there are 6 ways to get a double, but each one of them, 1-1, 2-2, 3-3, 4-4, 5-5, 6-6, only occurs one time. So a 1 on a red and a 1 on a green is the same as a 1 on the green and a 1 on the red. So, okay, the final 2 examples, number 5, looks at not writing the entire sample space because the sample space is too big. So it says the administrative assistant at a local elementary school records the attendance for Monday. The school has 450 students. So 450 students. We want to come in and write what is an appropriate sample space for this event or experiment. So S can be maybe only one child attended that day, or 2 children attended, or 3, or ... to 450. So we're recording the number of students at the school on a given day. And the outcomes could be 1 child, 2 child, 3 child, all the way up to 450 kids, everybody there for the day. So notice we're not listing all of them out because it's a really large set. That's part A. Now part B says, describe the event E that fewer than 420 students attended that day. So you can do this a couple ways. You can come in and do 1, 2, 3, ... up to 420. Or you could come in and use our set builder notation. So I'm going to use A for attending, such that A is less than 420. So A is any number as long as A is less than 420. And again, you're still bound by the sample space up here. Part C says, let's describe the event F that no more than half the students, Well, that would be 1, 2, 3, ... Half of 450 is 225. So no more, hang on, I need to be really careful. No more than half, which would be no more than 225. Or, again, you could list that as A such that A is less than or equal to 225. Because this one includes the half. So I need to go back and change the previous example because we need less than 420. So this statement and this statement are not saying the same thing because we want less than 420. It says fewer than 420. So this is going to go to 419. Sorry. So now this one and this one read the same way. Okay, and then our final example. For this part says let S be a sample space for an experiment. In this case, it's X, Y, Z. So picture that spinner again with just 3 regions this time. One's X, one's Y, one's Z. So we want to, with the outcomes X, Y, Z, list all the events. Of this experiment. So what they're really asking us to do is to list the subsets. Right back into chapter 6 with vocabulary and what subsets are. So one possible subset is just the set X. So this set is completely contained within this set. Well, if we can have just X, then we can have just Y. We can also have a set that is just Z. Or, if you remember what we did is X comma Y. You can also have X comma Z, or you can have Y comma Z. And then there's 2 more that are subsets. So the original set is a subset of itself. So X, Y, Z is a subset of X, Y, Z. Then also the empty set. So there are all possible subsets or events that could occur associated with this sample space.